Hello, everybody. Welcome, and thank you for joining us today. This morning, we're going to talk about some of the practical kind of applications of features used in Unreal Engine to develop tools, and the way which we did that to help support our team. First, I'm sure you're wondering, who are we? And maybe more importantly, why should you listen to us? We're from Summerfall Studios. I'm just going to quickly... a Melbourne-based independent game developer focused on creating emotionally fueled, character-driven narrative games for audiences who value rich, compelling storytelling over mechanically demanding gameplay. And that fulfills my obligation to the marketing department. So I'm Troy, not this one though, this one, significantly less famous, but I've been working in the industry for over a decade now, and I've been fiddling with Unreal Engine in its various iterations for 15 plus years now at this point.
I'm Alissa. I've been working in the industry for about a year and a half, but I've been using Unreal for far longer than that.
And we made Stray Gods, the role-playing musical. For those of you who are unfamiliar with Stray Gods, first of all, how dare you? But secondly, here's a bit of an overview just to give you some context.
Stray Gods is not your typical Unreal Engine game. We use very high stylized characters, 2D characters, and in a 3D environment. Most of our game is done in sequencer. Because we made an atypical game, we had problems that typical Unreal titles don't come up against and couldn't be fixed with typical Unreal tools. So we had to look outside the box to make things work.
We definitely had some help along the way, but Alissa and I were the core engineering team for the entire project. And we had to support a content team that was, I think at our peak was about 23 people. So it's quite a big difference. And we hope that some of the insight that we can give you today is about how we were able to do that, have a small team, make a big difference. Which I think something that Bill touched on earlier. So I'm glad that was said. So firstly, we're going to talk about sprites, and sprites and sprites and sprites and sprites and sprites. So as I mentioned, Stray Gods, we used a mixture of 3D environments and 2D character assets. So you can see here, this is an example. Our character here, Grace, is a texture just being rendered on a 2D plane, just placed in the world, in the environment. We used paper 2D sprites because they kind of gave us a lot of stuff out of the box, and we didn't really need to do much more than that. So this, I'm sure you'll all agree, please, that this looks amazing. It's a really high fidelity, kind of like stylized art style, but it did lead us to a few problems. To make emotionally fueled games, like I said we wanted to in the beginning, we needed to be able to emote. We needed our characters to be able to emote. And to do that, we needed to animate them in some way. Not as much as traditional animation. We went with much fewer frames because that wouldn't have been feasible. But we did need a lot of different expressions and poses to kind of like get that emotional across. And that results in needing a lot of different textures that we can put on planes and stick in our world. We tried a few ways to kind of like solve it with tech, but none of them didn't compromise our artistic vision enough. So we ended up having a solution where we just needed to make individual sprites for everything. We can see, I've got some stats up here. we ended up with about 7,200 individual sprites. That's a lot, especially like for a small game. And the artists worked in stages. So they went through, they did roughs first, and then they did some inks, and then they took it to a flat, and then they took it to fully rendered. So that acts as like a multiplier on that number as well. So we actually ended up with like just shy of 30,000 individual like assets that we had to kind of manage. And we were really worried about human error in managing that, because even if we had like a 1% error rate where we had to fix some sprites, that's like 300 sprites. Like the 300 issues that we have to track down and find and fix and whatever. So the second problem we ran into is that we couldn't wait either. We had hours and hours of content that we needed to generate using these sprites, and we needed to start doing that as early as we could. If we waited, I think the last batch of sprites that we did came in maybe a week or a couple of weeks before content lock was in. So if we had have waited for all of those sprites to be done, that would have doubled our development time, doubled our budget. Like that was just something we couldn't do. This meant that whatever solution that we did implement meant that we would need to be able to seamlessly update the versions of sprites that we were using along those stages to their most recent stage without needing to do that manually, because I was just going to move the work around instead of removing it. And that would also introduce another point of failure, which we were already worried about. Oh, my screen's gone blank, sorry. Okay. So faced with those two kind of problems, it's blank again, okay. Faced with those two problems, we did what any good engineers would do: automate it. Also known as giving it to our computer overlords to do. So we had a look at like the stuff that we kind of had already, the things that we could leverage and piece together. We already had like a centralized location for all these assets to live. The artists needed this so that they could do their job and find out what was missing, or if anything was missing, or what needed to still be done. So that was really handy for us. There are Commandlets. If you don't know much about Commandlets, I'm going to get into a bit more, but essentially they're kind of like ways that you can get Unreal to run kind of arbitrary programs inside its sandbox. And we already had a build server continuous integration kind of pipeline set up. Very basic one, but we were able to kind of leverage that as well really easily. So with those in place, I think we kind of had everything the basics that we needed. We could just have like a build server, kick off a commandlet that would like scrape all of our assets and kind of like import them and do stuff like that. So yeah, we had all the ingredients for an automation cake. We just needed a recipe. So we took those and started to fiddle around a little bit. My clicker's dead. I'm gonna go here real quick. Cool. So once we put it all together, this is kind of like what we came up with. So on this end, we had our artists. They would create their sprites. They would upload it to the sprite bank. Then we had a little piece of software that would scrape those, update like a list, save that data out for later consumption. We then had our build server run a commandlet that we wrote that would query that list and import the sprites that needed updating that it determined. And then once it had finished that process, it would push all the updates to our repository, because we are all using source control, yes? Yes. And then on the other end, the cinematic editors would just get their sprites and they could continue working. They'd get their updates and they could go about their way. My clicker's still not working. Cool. So between these two, the last two slides, you can see that we introduced an intermediate step where we kind of like save that data out. We primarily kind of like did this for a non-technical reason. It let us like query it for other purposes. It was very useful for production to be able to get a handle on like what has and hasn't been done. Artists were able to really quickly look at it and say like, oh, this stage hasn't been done yet. I thought we'd done that, or we hadn't done it. Where is it? Whatnot. So that was really useful for other reasons. It did help us optimize the process a little bit, but that was kind of a small benefit. And it wasn't something that we really like counted on when we added that thing. You could have used thank you. You could use a database or something like that for this. We used we just used Google Sheets. There are advantages and disadvantages to both. For Sheets, for us, it was like human readable was kind of really like nice. We didn't have to write any extra tools to kind of look at it. Production already knew how to do that. They're in spreadsheets a lot already, so they could do their own queries and stuff without needing us to intervene. And on the rare occasion that something did go wrong, we could potentially also just go in there and like hand edit it if we needed to. But that is a bit of a double-edged sword, so kind of be careful with that. Excellent. Cool. Commandlets. So yeah, I mentioned they're kind of like little applications that you can kind of like get Unreal to run. You can do that by adding this run parameter to the command line. The commandlet class name is the name of the class that you make. I think it also does some like extra processing. So on this one, technically, if I did like run Sprite import, it will be like, this is meant to be a commandlet. So I'm going to like look for Sprite import, and if I don't find it, I'm going to look for Sprite import with commandlet on the end, which is sometimes handy. But there's a number of these built into Unreal, so maybe go have a look, dig around some of the documentation stuff. Like there's one for fixing up redirectors, which sometimes some of you may have had some issues with that. You can have like your build server just like do it every night, and then you don't have to worry about it. So Commandlets use a lightweight execution environment. There's stuff like, it doesn't load in maps, levels, it doesn't load in actors. It's kind of really stripped down. When I did my one, I also found out that it doesn't spin up the system that ticks the HTTP requests that I was using to download the sprites. So I fixed that, but so just be careful. Just be careful when you're kind of like looking for things and expecting them to be there. Sometimes they might not be. And just like a kind of like a C++ command line program, there's a main function that you override, and that gets called when you run with this run command, and it finishes execution when main finishes its execution. There's probably a little bit of cleanup in there as well, but I don't care about that. And kind of like, because they run from the command line, they're designed to be used non-interactively. They're really useful for automation. You can run them in build server processes and stuff like that really easily, and they kind of just do their thing and churn along, and you get great results, hopefully. So I'm just going to go over like what our commandlet did specifically. So we would, when it spun up, it would query the asset list that we had. It was pre-scraped already, so kind of already knew what sprites did or didn't need updating, so it was kind of really an easy process at that point. It would then, for each of those sprites that it's found, it would download them and import them into the engine. If the sprites already existed, so if there was another stage or if there had been updates, it would find that sprite and it would update it and replace the references for it. So again, that's seamless kind of like upgrading of versions. Otherwise, it would just create a new sprite and continue on its way. And then finally, we also had it create our paper 2D sprites and like regenerate those when it, if it needed to do that. It's a convenience thing. I thought while I was in there fiddling around with all the sprites, I may as well do that anyway, because it's just going to save us some time down the track. Okay, I did stretch the truth a little bit that last slide, but only for dramatic effect. The Commandlet didn't really do any of that. We wrote like a small little subsystem to do that instead, and then the Commandlet just kind of wrapped that subsystem. That was really useful for us because then we could also wrap that in an editor utility widget and give that tool to the cinematics team directly. If you are unaware or unfamiliar with editor utility widgets, they're like really super useful. They let you use UMG and Blueprint to create editor tools. Really quick, really easy to iterate on. If you get some artists that are a bit familiar with like Blueprint, then they can start to make their own little tools very, very easily. You can see kind of like this is an example of the tool that I'm talking about now. It's nice, it's dockable, it can run when the editor starts if you want it to. Really useful. And so yeah, by making that kind of like subsystem, we were able to just get this kind of tool for free. Was it worth it? Pan asks. It's hard to say. We identified this as an issue really early on once we kind of settled on the art style. But based off other asset management tasks and experience kind of within the team, we think that it probably saved like either conservatively like somewhere between half to a full-time role across the lifetime of the project. That's like hundreds of thousands of dollars, right? Like, and it came out with a low error rate. It wasn't perfect, forgive me, but I think our error rate with this was like 0.1% or something like that, really tiny. It was like a handful of sprites we had to adjust. And I think most importantly for us, it removed a bunch of work that didn't really sit in the art space, it didn't really sit in the cinematic space, and we kind of just, removed that chunk and like let the people do the work that they are good at doing rather than like other work. And that really helped us increase the quality.
So all of those sprites needed to fit into our stylistic environments. In order to maintain consistent characters, they were all colored with their lighting agnostic, so they worked well in the average, well-lit, warm environment. However, in some of our more dramatic and moody scenes, the differences were a little more obvious. You can see the original Calliope sprite here on the left. She's beautiful, she's great, she kind of sticks out. The one on the right is after she's been color graded. This is important because we had some maps like this one in Hades that were like cold and dark and mysterious. Also, at this point of the game, Calliope is dead. So we needed to make sure that she matched the other undead shades that appear in this scene. Being able to modify the grading was also important for our dramatical musical numbers, where the lighting could, and often did, change significantly from one moment to another. So we needed a way for them to blend with that, which means we needed to find a way to color grade them. What is color grading? On a basic level, color grading is manipulating a raw image to create a tone that fits the color palette unique to the style and emotion of your story. In Unreal, color grading is typically done through post-processing and the colors full areas of the map, which was our first problem. Because of the way we set up our sprites and environments, simply using a post-processing effect wouldn't work. We needed a way to affect only our sprites without changing the look of our bespoke environments. And we needed cinematic control over where and when to grade any sprite in specific ways. Problem 2, iteration time. In order to even start grading, we needed to be pretty far into the development pipeline before we could figure out what we needed to do to grade them. The environments needed to be as close to final as possible. The cinematics needed to be close to final to know what kind of lighting situations would occur in different scenes, and the characters needed to be fully colored in order to ensure the grading was done correctly. You can see Grace here in the front in the dark seats and Asterion in the spotlight on stage. I'll come back to that later. Our initial thought for this process was to use lookup tables, or LUTs. But we realized that in order to reach the quality we wanted, we needed to make a LUT for each character in each environment under multiple lighting possibilities, which was doable as a process, but our artists didn't have enough time as it was. So instead, we built the process from scratch. We made a more streamlined color grading pipeline. This allowed the art team to grade the sprites as desired based on our needed parameters. In order to do that, we had a chat with our art director, Benjamin E., about how he would normally create a LUT to color grade a character and develop the pipeline based on his process. The first step was figuring out how to modify the sprite the way we needed it. We had Ben walk us through the process in Photoshop, what each part did and how he used it. From there, we had to figure out the math involved to make those adjustments, and as someone only vaguely familiar with digital art tools, that meant a lot of research. We ended up referencing open source art software to figure out the math that they used, which was incredibly helpful. And we were able to create material functions controlled by material parameters to modify the color balance, the white-black levels, the curves adjustment, and HSV adjustment of the sprite material. After a few weeks after making these material functions, an Unreal plugin dropped that did exactly the same thing, which is fine. The second step was creating an editor widget tool that we could use to modify those material parameters. We imaginatively named this the color grading tool. We hooked it up so that when you were working on a sprite in a sequence, any adjustments you make to the material are reflected live in the scene, as you can see here. It was also designed with a lot of collaboration with Ben so that we could mirror the workflow of his typical grading process. This was done by hiding some mathematical adjustments behind the scenes, tweaking the UI input scaling so that it fit a little better, and adding some quality of life adjustments so it had a similar feel to his normal tool. But that just allows us to grade one sprite. In order to unlock the full potential of our process, we needed to create one final aspect. We needed to be able to grade different amounts of sprites, from a vast area to an individual in a sequence, and change their grading at will. To do that, we created a color environment so that any sprites within it can find the appropriate grading data based on that space. Using the volume allowed the artists to create and place them at their will, allow them to overlap multiple, and define which ones they wanted to have controls of the sprites that appear within it. You can see here, this was the same shot as before. Grace and Freddie in the front are in their own seats, dark color environment, and Asterion on the stage in a separate one. The grading data made with this tool was used to set the color for all the sprites in the area for specific characters or for specific instances of a sprite in a sequence. And additionally, you could create keyable profiles so that the cinematics could control these in a sequence during a significant moment or slightly modify it over the course of a few. In this scene here, in this song here where Asterion's on the stage, the spotlight turns on and off, it changes colors, and the cinematic team were able to key those moments where appropriate. So was it worth it? Let's compare it to our most reasonable alternatives, the LUTs. This is Ben's typical process for making a lookup table. You go through the scene in Unreal, you take screenshots of the character from each lighting angle, you import those into Photoshop, you color grade the characters where Ben makes the adjustments to make sure it has the desired effect. You export that into a LUT, you import that LUT into Unreal and apply it to a character. You then have to review the scene to make sure that it goes through fully throughout the whole sequence, and then you have to continue that, rinse and repeat until all the characters are done. This is the process with our tool. You play through the scene, you make adjustments as you go. This tool allowed us to cut out a huge portion of our pipeline, creating a very tight iteration loop. It saved us some much needed time and effort by cutting out a lot of that context switching and keeping all of the work in one place so the artists were able to get into the flow of the process. The similarity between our custom tool and the art team's usual workflow let us reduce their cognitive load and minimize the need for them to retrain. This allowed them to focus on what they were best at and achieve the best results they could. All of that not only saved us time, but also scales well, and when we needed to add more content, its effectiveness was noticeable. In the end, building a custom tool from the ground up got the job done, and we were able to empower the art team and better meld the characters into our environment and emphasize the cinematic storytelling.
In case you hadn't realized by now, cinematics were a really big part of our game. So it made a lot of sense for us to spend a bunch of time trying to look into the cinematics team's workflow, figure out their pain points, and try to address them and increase their efficiency. Here are some stats. We spent a lot of time in Sequencer. We had about 4,700 unique level sequences, totaling a total duration of about 17 hours of content that we made. And we estimate the ratio of like dev time to output time is about 600 to 1. So for every 1 second of footage made, we were spending about 600 seconds to make it. So first thing, creating sequences in this environment was tedious and error-prone. We had 4,700 sequences, as I said. We had 9,300 lines of dialogue that we had to fit into them. And assuming about 10 seconds per operation there, which is conservative, I think. That totals about 40 hours of work. And that's not taking into account any errors that we might have to fix from that process. And that's a lot of work that no one should have to do. So we didn't. What we did instead was we leveraged all of the data that we had that was already in the engine. We wrote all our narrative inside custom tools that we built, so it was all there, all ready for us to grab and to use it how we see fit. So we wrote a little tool that would go through all of our narrative content, create any necessary sequences, and fill them with the relevant dialogue. And that just saved us a whole bunch of time and effort. I think this is a really good argument for keeping as much data as you can either inside the engine itself or really easily accessible to the engine. For a lot of our transitions and stuff, we wanted to have like fading in between different poses, which you can kind of see here in this GIF. Yep. That's great. That's really easy, right? Just a couple of keyframes, etc. But as I said, we did 17 hours of footage with like thousands of sprites. Like, this is something we did a lot. And so we identified this as somewhere we can maybe make some savings. So again, we built a little editor utility widget tool that would just like add some keyframes to a selected track in Sequencer with some preset alpha values. And just with this, we reduced the number of clicks needed to add in like a fade from 12 to 4. That doesn't sound like a lot, but again, we had 17 hours of content. We suspect and I think this is also pretty conservative, that over the course of the lifetime of the project, we saved 750,000 clicks. If you think about a click being like 1.5 seconds, that's 13 days of time spent that we saved clicking. And in addition to the savings we got in time, we also saved some of our team members' health. That's prime for RSI territory. I say not as a doctor, please take that with a grain of salt. So I think this is one of the better tools that we made, and it sounds really simple, but it could be easily something that you might look over. Early on, we ran into an issue when we were making our sequences. We found that sometimes there was the sprites that we were transitioning between would like pop in and out, like there was like a weird kind of like gap, even though all their frames were lined up fine. And when we looked a little bit deeper, we found out that it was this little asterisk up there that was our problem. If any of you are not sure what that means that the frame is actually on a subframe. Unreal is obviously not traditional kind of like film. Even if you set it to 30 frames per second, it's running in its own increments, and so it can actually do subframes. And so we had an issue where the transitions were like not on the same subframe, and that left a little gap, and that was enough for a little blip. You might think that that's maybe not a big issue for us. Maybe we're making a mountain out of a molehill. But we actually thought it was bringing our quality down quite a lot. And it was something that was easy to miss if you're just like scrubbing through a timeline. It's tedious to track down. If you're playing the game and you see it, you're like, oh wait, where was that? What's this? Hang on. And it had a high likelihood of occurrence, because if you're just like moving around like things or adding keyframes and stuff like that, like it could happen really easily. Now you may think that I'm going to say, we wrote an editor utility widget tool to like help fix this. That's where you're wrong. We leveraged another feature, data validation. This is a really simple and powerful plugin that's in the engine. You can get it right now, it's all there. That lets developers create custom rules and validate assets against those rules. Some things that you will find common examples of using it for is like enforcing naming conventions or file size limits or checking dependencies or something like that. There are a couple of ways you can get your data validated. You can do it manually through the context menu in the content browser. You can validate all the assets in a project, either via the tools validate assets context menu in the editor or by running the data validation commandlet. And the final way is enabling validate on save in the project settings, which will mean that when you save an asset, it validates it. We went with validate on save because we got immediate feedback, and that meant that people could like immediately fix the things that they had cropped up in there right away. Adding a new validator is really easy. You can just derive from this editor validator base. It is exposed to C++, Blueprints, and Python, so whatever environment you're most comfortable with, you can just work in that straight away. Once you've got your base class, you've got two functions that you need to override. Can validate, that just says whether or not the asset that it's trying to validate should use this validator or not. And validate loaded asset, that's where you define all of your tests, and you can check to see whether or not it's valid or not. And those are the signatures there. I haven't done it myself, but according to the documentation, you can also overwrite uObjects is data valid, and that also gets checked during these validation processes, but you'll have to try that for yourselves. And then in your validate loaded asset function, there's a couple of functions that you kind of like need to call during that to mark the asset. There's asset passes, which passes the asset, says this is valid, all checks have passed. You've got asset warning, which you can supply a message to, and that gets displayed to the user when it gets validated, saying, hey, something might be wrong, check it out, but otherwise continues the process. And you have asset fails, which does the same thing as warning. It lets you display a message to the user and then nixes the processor. And that's actually all you need to take advantage of this. It's this, as I said, simple and powerful plugin. In our case, we set one up so that whenever we saved a sequence, it would scan it, grab every keyframe, and just truncate the subframes of that keyframe so they all lined up perfectly. And it happens seamlessly, non-intrusively, and is part of the workflow. You can't not save your file, so it can't not happen, and all your stuff stays in like a valid state. It's really useful. A little bit of a lightning round, just a couple of small things to finish us off, because I think we're close anyway. Scripted actions, really useful for getting functions into the hands of other developers. You can subclass asset action utility to add functions to assets in the content browser, or actor action utilities to add them to actors in the world. And they just show up in this context menu under scripted actions you can see up there. This was built in UE4, so this has changed a little bit. The get supported classes is now, instead of a function, it's now like a property of the class you override, but it's essentially the same thing. It just says which things does this show up for? And really handily, if your functions have parameters, they will actually, you get a little pop-up when you run that action that lets you input those parameters. Helps like parameterize your functions that you're doing and give the user a little bit of control. So you don't have to make like 5 different things with like 5 different like values or something like that. Call-in editor, really handy. There's like, if you in Blueprint, there's a little checkbox on each function that you can check, seen at the top. In C++, you just use the call-in editor U function specifier. And then you'll get this down here in the details panel of an actor. You'll get a little button that when they click, the user clicks, it just runs the function. Really, really handy. One caveat is it only works with functions that have no inputs and returns void. So there's like limitations, but everything's got limitations, so use where applicable. And last thing I want to touch on really quickly is extending the editor's UI. It's a lot simpler than you might think. It's built for extension, and there's a couple of things you can leverage to kind of like start rolling with that. There's a setting in the project setting, in editor preferences, sorry, display UI extension points, and then you'll get all these little green texts on all over your UI, and that's just the name of the place that you want to start injecting your own UI elements. In UE5, you can use this this console command in the editor, toolmenus.edit. That lets you like click on them and actually get like a window that gives you all of the information. You had to kind of dig through UE4 a little bit to get that. So that's made that a lot easier. And then once you've got that extension point, you can use the uTools menus, extend menu function to kind of like start just adding stuff. That's the native kind of interface for that. Hope you like Slate. There are ways you can do this in Blueprint as well. They're less robust because you don't have access to Slate, but it does have a bunch of pre-existing stuff that you can kind of plug in pretty quickly. So like for us, you can see up here, we just made a little button in the sequencer window that would like rename tracks to be the name of the sprite that is actually on that track, just so that cinematics could keep track of like what was actually there, and they could keep an eye on things a little easier. So just going to start wrapping up here. Big things don't need to come from, big savings don't need to come from big things. Sometimes little things, lots of little things can add up to big things. There's a lot of powerful features in the engine. It's a big thing. It's hard to keep track of it all the time, even if you're keeping up with stuff. So maybe like just be a little bit active about that. Dig through the plugins list once in a while and see like what stuff's been added, because there's some gems in there.
Don't be scared to roll your own solutions. Sometimes existing tools or workflows don't suit your purposes perfectly. And in those cases, sometimes it's better to just write something from scratch than try to retrofit it. Tools are best developed in collaboration with their end users. Working closely with your teams can help you pinpoint areas where you can get the best bang for your buck.
So I hope we've introduced you to something new or something to think about, whether it's a tool or feature or a thought process or something. And I hope you can take something away and help empower your teams. Do we have time for questions? I don't know. I don't know who's running this. So.
I think we can maybe fit like 2
okay, cool.
at best. Raise your hand if you're...
Yeah, you got questions?
Well, this was eager.
Good.
Hello. Question I have, earlier you mentioned things like your Sprite bank, and you talked about your integrations with source control and all that. Could you go through maybe a bit more specifics on like, was the Sprite bank like just a Google Drive somewhere, or were you on Perforce or Git? Just a little more of those specifics to kind of see how you integrated into those other external tools.
Sorry, I didn't quite catch all of that.
Yeah, the other external tools that you mentioned as part of the earlier process, like the Sprite bank. Or the source control stuff. Yeah. Like, can you just go into those a little more?
Sprite Bank was Google Drive, but like again, you could use whatever would suit your purposes. We use Subversion because it's the thing that I'm the most familiar with, and I didn't have a lot of time to kind of like research alternatives. The editor has got some source control plugins that you can use as well. They're super useful. UE4's ones, at least for non-perforce ones, were maybe a little slow, but UE5's ones have been improved dramatically. So if you had looked at that and you're like, revisit it and check again, because they really helped our team out a bunch. Any other questions? Oh, we got one down here. Chris? Yeah?
Hi, Troy and Alissa, thank you so much. I'm also looking to make a game that's principally a story-driven experience as its first port of call, and I was wondering what both of your suggestions or learnings or recommendations would be for someone who's also trying to go on a game development journey in that same spirit.
Oh. I'm not sure how qualified I am to answer that if I'm understanding what you're actually. I mean, from my experience, mostly from like a tools point, it's like listen to the people authoring your content and help them make the best things that they can make. Often, I think that you can maybe get into the idea of like, oh, I know how to fix this, but like, maybe you don't actually really know what the problem is. Like, and so working closely with your team members, I think, would be the idea that I would go with. But I'm not sure it answers like a story-driven first kind of thing. I'm not really the person to ask. I don't know if you have anything to add.
I think we sort of focused on like, you kept your vision very clear from the beginning, right? Like, there was the thing that like the storyboarding team and the cinematic team, like they worked together to like really try and target their audience and like what the story they wanted to tell, so that like the emotional moments really hit. And our job was just sort of support them through that. But yeah, I did a little bit of the cinematic stuff early on just to sort of understand how that part of the system worked. And it's interesting, it's tricky, but it is like, you just kind of need to connect with your story and your characters and like work within your scope and your limit, because oftentimes that's the thing that kind of gets in the way.
All right. Thank you all for coming. We'll be